Now let me go ahead and explain how this software can work really well with our DSP software, which is ControlBase. So what I'm going to do is I'm going to go ahead and hit escape, and I'm going to go here and I'm going to just delete all. And I'm going to choose everything. So we're starting completely fresh here. And one piece of advice is when you're starting to get used to PredictBass and understanding how sound works in a room, my recommendation is start by just placing subs in here without placing any surfaces first. Get an intuition, get an idea of how the different sources interact based on the placement, especially if you're doing arrays. It's much more easy to understand how the different array configurations work when you're here in like half space, rather than you're trying to think, okay, am I seeing this null here because of reflections, or is it because of me, building this array or building the array improperly, or other trade-offs that can happen. So my recommendation is when you're starting with PredictBass, just start here and don't build the room, don't build any surfaces, build your arrays, and then you can go ahead and build your surfaces later, or once you get an intuition and you feel comfortable, then you can go ahead and start seeing what can happen. One of the main things about PredictBass that we hope comes across as you use the software is you can't really EQ a room. You can't really say, okay, I'm going to, take my measurement microphone and change all this equalization, and then now it's going to sound better in the room. The problem is by doing that, yeah, maybe it sounds better at a certain point in the room, but you've simply moved the problem elsewhere in the room. Now, that's not to say that's a bad thing. Now, maybe there's a place you want to move the problem somewhere else, or you want there to be nulls in a different place, and that's where room correction can be helpful. But I think I've found that there are a lot of people that have the perception that you can just EQ a room and make the whole room sound better in every single position. And I just don't think that's a helpful mental model to have when it comes to approaching room correction. I think instead, when you think about room correction and prediction, you should think about the different trade-offs there are and trying to get it as consistent as possible in the areas that you would want to optimize. So I'll get off my soapbox here, and what I'm going to do is go ahead and start by building an endfire array. So what I'm going to do is go to the speaker and I'm going to choose an SSP 118. This is an easy box to work with. You can see them right behind me here, looking very nice. And I'm going to just start by placing 4 of them. So I'm going to place one here, place one back here, place one back here, place one back here. So I've kind of roughly placed them where they want to go. And now what I'm going to do is actually start by creating the array of the boxes here in virtual space. So I'm going to go to my table view, and I'm going to go ahead and adjust the positions. So let's start with box number 1. So I'm going to set this at 30 in the X, and I think 15 is a good starting point. The next box I'm going to put at 30, and let me go ahead and do a 4-foot spacing between the boxes. So we'll do 30, and 15 plus 4 is going to be 19. Then we're going to do 30, and 19 plus 4 is going to be 23. And then we're going to do 30, and 23 plus 4 is 27. So I think I've done my math right. Let's go ahead and see what we've done. So we've created the boxes here in this kind of configuration. Of course, we haven't added any delays, so this isn't really a true endfire array yet, but you kind of get the idea of how you can place the boxes and adjust the spacing. And now what we're going to go ahead and do is we're going to go ahead and add delay to the boxes so that we can actually create that standard array. Now again, this isn't a ton of boxes that you're going to get the best array performance, but just for illustrative purposes, hopefully you get the idea here. This is going to be the box that we're going to set to 0. The back box is the one you want to set to 0 milliseconds here in delay. And then we need to delay the other boxes based on the arrival time so that they're all basically timed to this back box. So we need to do a little bit of a calculation here. So the speed of sound is about 1125 feet per second, and we have a 4-foot spacing. So let's go ahead and we just open up my calculator, and I'm just going to choose 1125 feet per second divided by 4 feet. 4 feet divided by 1125 feet per second. And that's about 3.5 milliseconds of delay we should add to each box, but of course for every 4 feet. So we're going to have to multiply that number. So this first box, I'm going to go ahead and set this to 3.5 milliseconds. This second box, I'm going to go ahead and set to 7 milliseconds. And then this box, I'm going to go ahead and set to 10.5 milliseconds here. So yeah, just making sure that I did this correctly. Again, if you go into the table view and under speaker settings, speaker placement is just for placing the speakers or choosing the models. Speaker settings is where you're going to see all of the kind of more of the control that you would want to have over the speaker once you've placed it. And again, I'll come back to this in a second. Here's what we have. We have these various speakers, and maybe at this point it would be helpful to just name them. So kind of based on the delay, this is like far back, this is like mid back, this is mid front, and this is like far front, so that we have all of them in a line. And now what you see here is I've actually gotten I've aligned them so that they're actually all hitting here, and you're seeing this nice kind of summation of all the boxes right out here in front. So this is kind of what we see with the endfire array. Now what happens when I walk to the rear? Again, of course, you're going to have all your nulls and weird pattern behavior on the sides because they're all, when you're standing here, you're equidistant from all the boxes, but the delay is kind of pushing each box back in every direction. So that's why the different arrival times are creating these various nulls when they sum together. And then as I come to the back, what you see again here is you see that rejection, that rear rejection that you get from this endfire array that you see. So you're kind of pushing each source forward, and this is how you would build it. So what you would do at this point is you would open up ControlBase, and I'll do this here in a second, and you would go ahead and enter these settings in from the table view. So here I go into my table view, and I go to speaker settings, and of course I had this one in preset 7 from before. Let's go ahead and set this to preset 1. Now what we're seeing here is, this is the various settings for each of the boxes. You see the presets, you see the delay that we've set them to, and then of course the gain, but this is kind of just a normalized value. So let me go ahead and open up ControlBase. Now I don't have any boxes connected here, but what I can do is enter the demo mode. And basically you can imagine that there would be 4 different boxes. So we would pull it up, we have our milliseconds, and we could go ahead on each of these boxes is open them up and go ahead and put 0 for the first box, 3.5 milliseconds for the second box, 7 milliseconds for the third box, and then of course 10.5 in for the third box. You'd open each one up and you would set the settings, and that's how you would use PredictBass in combination with ControlBase to kind of set your various settings and create your subwoofer arrays. So again, PredictBass is really useful for coming in here and deciding maybe how big should your array be, how can I do the array prediction, these sorts of things. And then you go into ControlBase and you can just simply copy those settings over. One thing we are looking into is a way that we can interface PredictBass with ControlBase directly. Again, we don't have anything to announce at this time, but we realize that would make things very easy. Again, if you could do the prediction and then link each box as you go. The other thing I'll say is we are looking into a very highly requested feature, probably number 1 on our list, would be having our various tops in there. And from there, what we could do is we could look at the various patterns. Again, that's something that we're looking into. We don't have anything to announce now, but we would really like to add the top boxes as well, so you get an idea when you're building a venue of, hey, where should I be placing my tops to get optimal coverage in these various areas? Again, the whole philosophy behind this isn't to try to say, here's the number 1 place, here's the only place you can put your speakers. You know, some people say, tell me where to place my speakers. And really the point is it's more complicated than that. So rather than us throwing up our hands, the idea is we want you as the customer, as the purchaser, to understand the pros and cons of placing your speakers and to get a better idea so you can deliver better sound and better sonic impact to your customers and at your shows. So thank you all so much for your attention. We really encourage you to head on over to our website and download PredictBass. It's free. You can download it today. You don't even have to own BASSBOSS products to download the software, though we encourage you to put the BASSBOSS products in your virtual room, and once you get an idea of how that's going to respond, to put them in your actual room. So thank you all so much, and we'll see you at the next show.